Hey guys, happy Monday. We are going to look at 3 examples of molarity. We've already gone over this before we were home for the quarantine. We did this stuff in class, but I know that feels like a really long time ago for me, so I'm guessing it probably feels like a long time ago for you guys too. So we're going to go back over all 3 different types of problems, one example of each, and then you've got some practice to do in the PowerPoint as well before you take your understanding check. This stuff is going to be important for what we are starting tomorrow, which is stoichiometry using this molarity information. So if you're feeling shaky on molarity, hopefully this review helps. If it doesn't, definitely check out office hours, use the chemistry website, go back to your practice in your green book, whatever you need to do to make sure that you are solid on molarity before you start solution stoich tomorrow. Okay, so starting with what I think is the easiest type of problem first. This problem is asking us to look for a molarity. Okay, it says, what is the molarity of an aqueous solution with a volume of 450 milliliters that contains 200 grams of iron 2 chloride? So when I'm looking for a molarity, I know that I'm going to start by putting my mass over my volume, okay? Because molarity is always that measure of mass over volume, usually in moles per liter, but in this case, we're going to have to convert our units to get to moles per liter. So we know we're using iron 2 chloride, so we get a little naming practice here. Remember, this 2 tells us the oxidation number on iron, so iron 2 chloride is going to be written as FeCl2. So again, something to keep in mind as we do this problem, we're going to need a molar mass, so we need to make sure we have the correct formula. Okay, so we said we needed to put mass over volume here. So we're going to take 200 grams of FeCl2. We're going to put that over our volume, which is 450 milliliters. Okay. We're trying to solve for molarity. Remember, molarity is moles of solute over liters of solution. So we're just going to keep that in mind. That's our end goal. So looking at our units, we've got grams and milliliters. We need to take grams, convert it to moles. We need to take milliliters, convert it to liters. It doesn't matter which one we do first. Either one works. So let's go ahead with grams first. Okay. Using our periodic table, we know that the molar mass of iron 2 chloride is 126.75 grams per 1 mole. Okay, we always want to cancel our units. So grams of FeCl2 cancels with grams of FeCl2. And here's my moles. I'm circling this because this is an end unit that I want to get to. So I'm not going to convert that anymore. Now I have to deal with the milliliters. I have 450 milliliters. I know that 1,000 milliliters fit into 1 liter. So again, milliliters cancels with milliliters. I'm left here with liters, which is my other end unit. Remember, molarity is in moles per liters. So when I figure this out, I want to keep moles, I want to keep liters. So I'm not going to cancel those out. I'm going to multiply my numbers across the top, divide by anything that's on the bottom. When I do this, I'm going to keep in mind order of operations in my calculator. I'm either going to go step by step or make sure I use parentheses. I should get an answer here of 3.51 molar FeCl2. Again, that's 3.51 moles per liter, which we write as molar. Okay, so that's our first example. That's a problem where we're going to calculate molarity. Here in our next example, okay, this one we're asked how many grams of potassium carbonate are needed to make 200 milliliters of a 2.5 molar solution. So now in this case, I'm going to solve for grams. I can tell that because I'm given my other two pieces of information. I'm given a volume and I'm given a molarity. Okay. Again, we've got a little practice with naming. We're told that it's potassium carbonate. So I need to know that that's K for potassium, CO3 for carbonate. And then we've just spent a lot of time practicing with our oxidation numbers. We know that CO3 is a -2, K is a +1. To make those equal, I need 2 +1s to match up with my 1 - 2. So I end up with a compound that's K2CO3. Again, I'm dealing with grams, so I'm going to need a molar mass at some point, so it's important that I have my formula correct. Okay. So looking at this one, anytime we're given a molarity, we know we need to split this up. Okay. I like to do this step first. You can do it later. I just think it's easier to get it taken care of right away. So I know that 2.5 molar means that it's 2.5 moles of K2CO3 per 1 liter of solution. I know that's going to be important in this problem. Okay, so I'm going to start with this. I'm going to start with my 2.5 moles K2CO3 per 1 liter of solution. I know I need to get into grams, and I know I have milliliters that I need to use somewhere in this problem, but right now I'm in liters. So just like the last problem we did, you can do these in any order. Okay, I'm going to start with my grams first, or my moles, and then I'll take care of my liters and milliliters. So just like last time, I've got a moles, I've got to turn it into grams, so I need to use a molar mass. In this case, 1 mole of K2CO3 is the same as 138.19 grams K2CO3. So here moles are going to cancel with moles, and I'm left with grams. So this is the unit that my answer needs to be in. I still, though, have to deal with this liters on the bottom. And I know I need to use 200 milliliters somewhere in the problem. So I'm going to keep going. 1 liter is the same as 1,000 milliliters. Now my liters will cancel. I'm left with milliliters, and I can plug this number in from my problem because the milliliters will cancel. So 200 milliliters is my last step here. So now milliliters cancels with milliliters. I've canceled out all of my units except for grams, which is what the problem is asking me to solve for. So I'm ready to multiply all of my numbers on the top, divide by anything that's on the bottom. When I do the math, I should find out that I get 69.1 grams of K2CO3. Okay. Last problem here. I think this is probably the trickiest of the three. We're going to be solving for liters in this problem. Okay, it says how many liters. When we do this, remember liters is on the bottom of our molarity, so we're going to have to flip that proportion. So we'll look at how to do that. It says how many liters of 0.88 molar solution can be made with 25.5 grams of lithium fluoride. Just like last time, I've got to figure out what this compound is. Lithium fluoride, LiF. Lithium is a +1, fluoride is a -1, so they pair up evenly. I don't need any subscripts. I also need to break apart my molarity here because I'm going to need to use that in my problem. So 0.88 molar means that I have 0.88 moles per 1 liter. It's going to be important. And then I see my other piece of information in this problem is 25.5 grams. All right, I'm ready to start setting up this problem. Because I'm solving for liters, I am going to have to flip this proportion here. I need liters to be on the top, and right now it's on the bottom. So I just take it and invert it, flip it upside down. So I'm going to start by writing 1 liter over 0.88 moles of lithium fluoride, LiF. Okay. My clue here is anytime it asks me about how many liters or how many milliliters or what volume, I have to start with volume on top. From here now, I just plug in the missing pieces of the puzzle. I should end up with liters being the only unit that I'm not canceling out. So just like all of my other problems, I have moles. I have to turn moles into grams, so I'm going to use a molar mass. This time, 1 mole of LiF is the same as 25.94 grams of LiF. I'm going to cancel moles and moles, so I'm with grams here. I'm not done with the problem yet because I still have another unit, but I know that I can input this piece of information from the problem because grams match up. So I am going to put here 25.5 grams of LiF. Now grams will cancel with grams. So the only unit that I have left here is liters, which is what the question is asking me for. So just like all the other problems, I'm now going to multiply any numbers that are on top, divide by anything that's on the bottom. Again, I've got multiple numbers on the bottom, so I'm going to make sure I keep in mind order of operations. Either I'm going to use parentheses or solve it step by step. When I get my answer, I'm going to have 1.11 liters of LiF, lithium fluoride. All right, so we've looked at 3 different problems here. We've looked at a problem where we solve for liters, a problem where we solve for grams, and a problem where we solve for molarity. Okay, in all 3 of these cases, we're going about the same process. It's just figuring out what we're starting with and what our goal units are, and then making sure that we don't cancel out those units. Make sure you check out the practice on the next couple of slides. It should come back to you pretty quickly. If not, office hours, chemistry website, green notebook, anywhere where you got additional practice is a good place to go. All right, hopefully talk to you soon. Bye.